Alright, so the entrance fee is $32, and you like this game, that's $2 a game. So write an equation to model your total cost for the day in terms of the number of times you play the game. Since it's $2 per game, that's going to be our slope. So it's y equals 2x plus the initial cost, which is 32. So to graph this, you need to come up with an appropriate scale. 1 on the x's, which is the number of games, is fine, so 1, 2, 3, and so on. And then on the vertical scale, we got to start at 32, and it's going to get even higher. So I think we should go by tens here. Looks like a good increment. So each box counts for 5. Now, so our initial value, y-intercept is 32. That's 35. 32 is right about there. It's hard to see exactly where these would line up, but to get to the 40, I need to go up 8 from 32. And if my slope is 2 over 1, that's the same as up 2 over 1. Can't really see where that lands. But I could go up 8, means I'd have to go over 4, and that would give me the same slope. So up 8 over 4, that lands right there. And then I'm going to do it again. Actually now, to land on a good mark again, I could go up 10 over 5. So up 10 from 40 to 50 is up 10 over 5. 1, 2, 3, 4, 5. So there we go. There's my line with a few good points on it. So use the graph to find the cost of playing 7 games. So 6, 7 would be here. It's actually not very easy to use the graph, but you can certainly plug it in as well. So pretend I use the graph, but I'm really not going to. 2 times 7 plus 32 equals 14 plus 32, which equals $46 total for the day. The slope represents the price per game, and the y-intercept represents the entrance fee, which is the initial cost. Alright, so a similar problem. We're driving a distance of 480 miles. They give us the equation, and constant rate of 60 miles per hour. So the distance yet to go, so how much, so they're 400 miles away, 480 miles away. We've traveled 0 hours, they're still 480 miles away. And then x is the number of hours since he left. So eventually, the distance will be 0 when they arrive. So the slope is negative 60. So the slope is the number in front of the x. And then the y-intercept would be 480. So if we're going to graph this, we again have to come up with an appropriate scale. So we're going to go up by 50s here instead. So this is 100, 200, 300, 400, 500. And then we're going to go over by ones again. So 1, 2, 3, 4, 6, 8. There we go. Alright, so our y-intercept is 480. So that's right about here. And then label the axis. So this would be the distance to go, and then this is the hours driving. So we got a y-intercept here. Let's find our x-intercept. So for our x-intercept, the y value is 0. So I'm just going to plug in y equals 0 to our equation. So that gives us 0 equals 480 minus 60x. Add that to the other side, so we have 60x equals 480 divided by 60, and I get x equals 8. So x equals 8 is my y-intercept, right? When y is 0, x is 8. So that gives us this. So there's our line. It should be straighter, my bad. Alright, so graph the equation. Now, what do the intercepts mean? So the x-intercept is at 8, 0, That means they drove for 8 hours, and the distance left was 0. So they arrived. They took them 8 hours to do the trip. Y, the intercept, is at 0480, and they haven't left yet. Because they've been driving for 0 hours, which means they haven't left. And they have 480 miles to go.